For the lesson 2.6 Ready, Set, Go, it's really trying to bring everything together as was discussed in class. So if you look, you've got two columns that you're working with through the whole thing. The type of growth for the first column, because we have this function here, it would end up being considered linear, as opposed to this model where we have an exponent be considered exponential. What kind of sequence corresponds to each? Well, we know that linear is an arithmetic sequence, and exponential is a geometric. The value of table of values, if I plug in 0, I would get 4. Plug in 1, I would get 7, 2, 10, 3, 13. So I'm just plugging in the x for that equation and getting out the y values. For this one here, plugging in a 0, 4 times 3 to the 0 power would be 4 times 1 would be 4. Plugging in a 1 would give me 9. A 2, oh, 36, and 108. So you can just see that we have a table of values that's being crafted from the problem. For the rate of change, looking at the table from the previous portion, you would see that you are adding 3 each step, and in this case you are multiplying 3 each step. To graph the equation, we would start off with our y-intercept, and we would go up 3 and over 1. So we're going to add 3 each next step. And because it's that equation, we would be able to clear that up. For the next one, again, it starts at 4, but it quickly goes up and up and up. So it's going to be an exponential growth. The y-intercept, b equals 4. So our y-intercept would be 0, 4. And the same thing is happening here. To find y-intercepts, the trick, the key, the thing to focus on is the y-intercept happens when x is 0. So we plug 0 in for x, and you find out what the y-intercept is. So in this case, the y-intercept would be 0, 0. For number 7b, 3 to the 0 power is 1. Therefore, the y-intercept would be 0, 1. I'd like for you to think about number 8 on your own, based on what was done in number 7. The set portion is going to be very helpful to, again, be able to tie everything together. The stuff that we just did in lesson 2.6 and also the work that we've done prior. So number 9 has a lot of words. The big thing to think about when depositing $175 a month consistently just means that every month she's depositing that $175. Been open for 10 months and has $2,475 in it. Create an equation for Jasmine. So we want to try to figure out what is happening, because we don't know how much she had initially. Now this one can be kind of tricky, because if we just put this into our formula, we might end up with some concerns. But we know that it's going to be linear, so we're either going to use slope-intercept, point-slope, recursive. And the thing I want you to think about is we know what our slope is. We know what our rate of change is. Our m is 175. The tricky part is knowing that we actually have a coordinate, a point. 10 months gives me 2,475. So I know that I have 10 months, $2,475. So I have an x1 and a y1, which means that I'm going to use point slope form. And when I write that out, I would end up with y equals, your slope is 175, so your rate of change is 175, x minus x1, which is 10 months, plus $2,475. For number 10, it's a problem that we've seen in a prior lesson, but we're using it to launch into a little bit more. So we have the number of rectangles created with 5 folds. Well, first of all, we're looking at this table here, and you can see that in order to get to each next step, we're multiplying by 2. And because of that, we know we have an exponential function. Well, I need to figure out if I'm going to use an explicit or recursive to get what I'm going for. I need 5 folds. I have 4 folds already. So it doesn't make sense to set up an explicit equation if I just need the next fold. What I would do is I would set up a recursive. So to write the equation, I would say that my first term was 2 folds, or 2 rectangles, and every fold after that, I took the previous one and multiplied it by 2. To find the number with 14 folds, it's a whole lot more. It's a lot of multiplying by 2. So if that's the case, we're going to talk about the explicit equation. And the explicit equation would be f of n equals my first term, which is 2, times my rate of change, which is 2, raised to the power of n minus 1. For number 13 and 14, it's the ability to analyze what you see. And what I see for number 13 is that I have an n in the exponent, means it's exponential. Okay. Then I know that if I can create a table, so this is actually n and y. If I plug in 0 for n, I would end up with 8, 1, I would get 4, 2, I would get 2, 3, I would get 1, and so on. I'm continuing to cut it in half every step of the way. So at 0 it's 8, and then 4, and then 2, 1, half, and so on. Because this is an explicit equation, I know it's going to be a continuous graph. Okay. And you would do something similar for number 14, noticing what is happening and then being able to graph it. For the go portion, it is really getting you to practice solving one-step equations. And in the description, it's giving you some properties that you can use. Really, I would be fine if you go through and you just complete the steps. And your justification might be that you are just dividing 3 on both sides. And for number 17, we're just going to use those inverse operations. And for number 19, again, just using those inverse operations. So hopefully this helps. Reach out if you have any questions at all.